today's lecture, we will discuss to find out the centroid of a composite figure. So to find out we will take one problem of high section. So this is a high section like this. This is a I section. The dimension of this I section are, this is 20, this is 2 millimeter, this is also millimeter, this is 10, this is 2 millimeter, this is 18 millimeter, and this is also 2 millimeter. So in this type of problem, we have to first fix the reference line. We have to first fix the reference line. So first of all, we have to see that whether this figure is symmetric about any line of axis, that is x-axis or y-axis. So we see here that this figure is symmetric about y-axis. We can see that this figure is symmetric about this line. So we know that if the figure is symmetric about a line, then the centroid of that figure is lying on this line of symmetry. So in this figure, the centroid of this total figure will lie over this line of symmetry. Now we have to take another reference line. So this is the reference line along x-axis. So we have taken this is a reference line along x-axis. Now we have to divide this figure in the well-known shapes whose centroids are also well known. That is, this figure can be divided in 3 rectangles, and for each rectangle we know that the centroid of a rectangle is at the midpoint of the sides, that is b by 2 or h by 2. Now for this is the rectangle number 1. Number the rectangles. This is rectangle number 2, and this is rectangle number 3. So we have divided this figure in 3 rectangles. One rectangle, this is first rectangle, and this is second rectangle, and this one is third rectangle. Now make a table. So serial number for the table, that is serial number. So serial number 1, 2, 3. Now the shape. The shape is rectangle like this. So this is second is like this, and third one is like this. So these are the shapes of rectangles. One number is like this, 2 is this, 3 is this. Now the area A. So area of this one rectangle is 20 into 2. Area of number 2 is 18 into 2. Area of number 3 is 10 into 2. So this is 40, 36 and 20. Now the distance x. This x. What is this x? This x is distance of individual centroid from reference line along y-axis. X is the distance of centroid from reference line along y-axis. Y-axis से जो reference line हमने y-axis के along मानी है, उससे जो distance आएंगी that will be x, and x is the distance of centroid, x coordinate. So x1 for figure 1. So this is figure 1 and this is the reference line along y-axis. So the centroid of figure 1 is lying over this line, because this is the line of symmetry for the whole figure. So this is also the line of symmetry for figure number 1. So x coordinate will lie over this. So x1 is equal to 0, x2 is equal to 0, and similarly for x3 it is also equal to 0. So for each 1, 2, 3 figure, individual centroids of 1, 2, 3 are lying over this line of symmetry. So x1 is equal to 0, x2 is equal to 0, x3 is equal to 0. Now y is the distance of centroid from x-axis. x-axis से difference, y क्या है? x-axis से distance है centroid की, मतलब y coordinate. So y1 is for one figure, first figure, y2 is for second figure, and y3 is for third rectangle. So y1 is the distance of centroid from the x-axis. x-axis से first part के centroid की y coordinate. So x-axis here, this one is the x-axis. From here, the y coordinate of the centroid of this figure. So this will lie here. So this is the distance of y1. So this will be equal to 1. Now for second figure is starting from this point, this line. Second figure is starting from this line and up to this line. So midpoint of this at 9 from here, from this line, the midpoint of centroid of this part 2 is at 9 millimeter from this line, but we are taking the distance from x-axis, the reference line. Reference line will be common for all three figures. For all the figures considered, reference line will be common, should be common. So the centroid of this will be lying here. This is 9 millimeter from here, but we are taking the distance from this x-axis, so this 2 will be added into 9, so this will be at 11. Similarly for y3, this y3 will be here, so from here it will be at 1 millimeter, half of the 2 millimeter, so it will be at 1 millimeter from here, but we are measuring the distance from this x-axis. So from here 2 plus 18 is 20 and 1 21. So this is 2 plus 18 20 and 1 21. Total distance is from here 21, or we can also find it by adding 18 plus 2 is 22, and from here it is below 1 millimeter. From here it is 1 millimeter from here. So from here it will be 21 millimeter. So this will be 21 millimeter. So y1 is 1 millimeter, y2 is 11 millimeter, y3 is 21 millimeter. Now we have to find out the AX and AY. So this AX is A1X1, A2X2 and A3X3, and A1Y1, A2Y2 and A3Y3. So A1X1 is equal to 0, A2X2 is equal to 0, A3X3 is equal to 0, and A1Y1 40 into 1, or this is 36 into 11, and this is 20 into 21. So this will be 40, and this is 36 into 11 equal to 396, and this is 420. Now the summation A is equal to 96. This is summation A, and summation AX is 0, and summation AY is equal to 6, 5, 8, 856. Now from the formula, X bar is equal to summation AX upon summation A. This will be equal to 0. This will be equal to 0 means it is lying over the same reference line. So as we have said earlier, this centroid of this figure will lie over this line of symmetry. And now for y bar, this y bar is equal to summation AY upon summation A. This will be equal to 856 upon 96. This means 856 divided by 96. This will give you 8.916 millimeter. So this is the distance of centroid from this x-axis. So for this figure, this is the distance of the centroid from x-axis. So this is equal to, now we can say that for this figure, x bar is equal to 0 and y bar is equal to 8.916 millimeter from the reference line taken. Now A1 Y1 is equal to, now the problem number 2. This problem is related to L section. So for this L section, this is a L section. The dimensions are like this: 60 millimeter. This is 100 millimeter. And thickness is, this is 10 millimeter. And this is also 10 millimeter. So this is a L section. We have to find out the centroid of this L section. So first of all, we have to see that this figure is whether symmetric about a line along x-axis or y-axis or not. So we can see that this figure is not symmetric about any line along x-axis or y-axis. So in this figure, we have to decide the reference lines. So in all figures, we will try to take the reference line at extreme ends. At extreme end. So the distance can be measured at one side. So in this figure, we have taken, this is x-axis reference line and this is y-axis reference line. Now we have to divide this figure into two rectangles. So we have divided like this. So this is rectangle number 1 and this is rectangle number 2. Now serial number is 1 and 2. Shape is, this is rectangle number 1 and this is rectangle number 2. Now area A1 is, so A1 is this part is, now this part is A1 from here to here. This part is A1. So total length is 60 and from this 60 this 10 is reduced. So A1 is starting from here. So this is remaining, the remaining length is 50. This is 50 for A1. This is 50. So for A1, area is 15 to 10, 15 to 10, and A2 area is 100, because now it is from here to here. So this is 100 into 10. Now X. So for X1 and X2. So X is the distance from the reference line along y-axis. So this is the reference line along y-axis. Now X1. So for this is one part. So in this one part, the centroid of this one part is, the length of the first part is 50 millimeter. So it will be at 25 millimeter from here. From here, mind it. 25 millimeter from here. But we are measuring the distance from this reference line. So this 10 should be added into this 25. So X1 is 35. Please be remember that this is 25 millimeter from here and 10 should be added into this, because we are taking the distance of centroid from here. So 10 plus 25. This will be equal to 35. Now for this, it is 100. So for this is 10 millimeter. So the X2 is at 5 millimeter from here. 10 is this. And X is the distance from y-axis. So the centroid will lie at the midpoint of this. So 10 divided by 2 is 5. So 5 is the distance from here. So X2 is 5. Now Y. Y is the distance from x-axis. So for first part, Y is the distance from here. So it is 10. So half of this from here. So it is at 5. And for this is the half of 100. So from here it is at 50 millimeter, because it is total. This is the second part. It is starting from here and ends at here. So it is the 100 by 2. So it will be 50. Now AX and AY. So A1X1 is 500 into 35 and A2X2 is 1000 into 5 and A1Y1 500 into 5 and A2Y2 is 1000 into 50. 1000 into 50. A1Y1 is equal to 500 into 5. 500 is here. A1 is 500. So 500 into 5 and A2Y2 is 1000 into 50 and 500 into 35 A1X1 and A2 is 1000 into 5. So now summation A is 1000 plus 500. So this will be 1500. And here summation AX and summation AY. So summation AX will be equal to 500 into 35 plus 5,000 plus 5,000. This will be 22,500. And here 50,000 plus 2,500. 50,000 plus 2,500. This will give you 52. Now X bar is summation AX upon summation A, and Y bar is summation AY upon summation A. So this will be equal to 22,500 divided by 1,500, and this will be 52,500 divided by 1,500. So this will be equal to X bar is 22,500 divided by 1,500. This will give you 15 millimeter, and this is 52,500 divided by 1,500. This is at 35 millimeter. So X bar is 15 millimeter. X bar is 15 millimeter. So the centroid of this figure is at, from here it is at 15 millimeter, and 35 millimeter is Y bar, that is from X axis. So it will be somewhere here. So this distance it will be somewhere here. So this distance is Y bar is 35 millimeter, and this will be at 15 millimeter. So this is the answer. So 15 millimeter is X bar and 35 millimeter is Y bar. Okay. Now the problem number 3. In this problem, we have to find out the centroid of the shaded area. So from this plate, a semicircle is cut down of radius 50 millimeter. So this side is 250 millimeter of this plate. This is 100 millimeter, and this is 300 millimeter. That this semicircle is cut down from this plate. So remaining part is this shaded part. So we have to find out the centroid of this shaded part. So for this figure, now we again draw this figure like this. So this is the figure. Now in this figure, we have divided this figure like this. So this is part 1. This rectangle, total rectangle is part 2, and this semicircle is part 3. So this is the center. So the total length is 250. Millimeters. And the diameter of this is 100 millimeters, because the radius is 50. And here it is 100 millimeter from here to here, and it is total is 300, so it is 200 millimeter from here to here, and this is 100 millimeter from here to here. Now we have divided like this. This triangle is one part, second part is this rectangle, and third part is this semicircle. So this semicircle is cut down. So this will be taken as minus. The area of the semicircle will be taken as with minus sign. So for this, first of all, we have to decide the reference lines. So we have taken the reference line along y-axis, and this is the reference line along x-axis. So we have chosen both the reference line, x-axis and y-axis. Now start the problem with serial number 1. So first part, second part, third part. Shape is shape. First is right angle triangle. Second is rectangle, and third one is semicircle. Now area A. So for this right angle triangle, A1 is 1 by 2 into base 250 into height is 200, because the triangle is height is of the triangle is from here to here, so it is 200. So half into base, total base, into 200. Now for rectangle, it is 250 into 100. 250 into 100. And this A3, this is minus. This will be of minus sign, because it is cut down from the whole figure. So A3 will be of minus sign, and this will be equal to pi into r square divided by 2, area of the semicircle. Now x1, x2 and x3. X is the distance from y-axis. X is the distance from reference line along y-axis of individual centroids. So for 1, this is a right angle triangle. So for right angle triangle, the distance of the centroid from this reference line is 2 by 3 of its base, because earlier we have told that the reference line, the centroid of the triangle is at base upon 3 from the right angle side, b by 3 from the right angle side. But here we are taking the distance from the smaller angle side. It is the reference line which is at the smaller angle side. So from here the distance will be 2 by 3 of its base. So it will be equal to 2 by 3 of 250. Base is 250. So it will be at 2 by 3 of 250. Now it is for x2. x2 is the rectangle. So it will be at 250 divided by 2, because 250 of this side and distance is half of this from here. So 250 divided by 2. Now for semicircle. So semicircle, for this semicircle the centroid will be at this line. For semicircle, individual centroid of the semicircle at this line. So this line is at a distance from this line, reference line is, this is 100 and this is 250. So from here to here it is 150 and here to here is 50. So 150 plus 50, it is at 200 millimeter. Clear? Now y is the distance from x-axis for individual figures. So y1 is the distance of centroid from x-axis for part 1. So this is a right angle triangle. So height of this right angle triangle is 200. So it is at 200 by 3 from here. From this line it is at 200 by 3 because it is right angle side. So from here it is at 200 by 3. But we are taking the distance from here. So it will be 100 plus 200 by 3. Clear? It is 100 from here to here, and from here it is 200 by 3. So it will be at 100 plus 200 by 3. Now y2 is at 50 from this line, because this is 100, so it is at 50. And for y3, now y3 for semicircle, it is from this line it is at 4r by 3 pi. So 4r is 50 by 3 pi. The distance of centroid of semicircle will be at 4r by 3 pi. Clear? So it is at above this line 4r by 3 pi. So now summation A is equal to 250 into 200 divided by 2. This is equal to 25,000. So A1 is 25,000. A2 is 25,000. And A3 is minus 5 into 50 into 50 divided by 2. 3926.99. 3926.99. This is A3. So summation is 25,000 plus 25,000 minus 3926.99. This is 46,073.01. This is summation A. This is summation A. Now A1x1. A1x1 is 25,000 into 2 by 3 of 250. This is equal to 25,000 into 2 by 3 of 250. Four one six six triple 6.67. A2x2 is 25,000 into 250 divided by 2. So this will be equal to 25,000 into 250 divided by 2. This will be equal to 3125,000. Now A3 X3. This will be equal to 3926.99 into 200. This will be equal to 785,398. 785,398. And this is will be O with minus sign. Summation AX will be equal to 41666.67 plus 3125 minus 785,398. This will be equal to 65,06268.67. now A1 Y1 is equal to A1 25,000 into 500 by 3. This will give you this figure 416666.67, and A2 I2 is 25,000 into 50 is equal to 125,000, and A3 Y3 will be of minus sign. So this will give you the summation AY. Summation AY is the adding both of these values and from addition minus this. So this will give you like this. Now x bar is equal to summation AX upon summation A. So summation AX is 6506.268.67, and summation A is 46073.01. So this is summation AX and this is summation A. So on dividing, this will be the x bar. Similarly, y bar is summation AY and summation A. So summation AY is this one divided by this summation A. So summation AY upon summation A, and y bar will be this one. So x bar for this figure is 141.216 millimeter, and y bar is 115.758. So these are the answer. So in figures, if the area is cut down, then area will be taken as minus, and if the areas are only added, like earlier two examples, in this example areas are only added 1, 2, 3, and here also added 1 and 2. So both areas are positive, only additions. But here the area A3 is deducted from this total figure, so this will be with minus sign. And in this problem, the answers are like this: x bar and y bar. Okay, thank you.